Every 24 hours, raw steel and polymer enter one side of a factory in Austria. On the other side, finished Glock handguns emerge, each one proof-fired with a live round before it ever leaves the building. 34 parts, no more. That's what stands between raw material and the sidearm carried by two-thirds of American law enforcement. How a curtain rod manufacturer built that system is where this story begins. In 1963, Gaston Glock established a small metalworking shop in Deutsch-Wagram, Austria. The company did not start with firearms. Instead, Glock and his three-person staff specialized in high-pressure polymer injection molding and metal stampings, producing curtain rods, doorknobs, and hinges. By the 1970s, the workshop secured military contracts for field knives, grenade casings, and machine gun belt links, gaining practical experience in combining synthetic resins with structural steel. The decisive opportunity arrived in 1980, when the Austrian Ministry of Defense announced a tender to replace its aging Walther P38 service pistols. Despite having no prior experience in firearm design, Glock recognized a manufacturing opening. He assembled a team of engineering specialists, analyzed the military's demanding 17-point performance criteria, and developed the first prototype series, labeled B1 through B5, in 1981. The design bypassed traditional manufacturing complexities. In 1982, after passing severe trials in ice and extreme heat, the Austrian Army officially adopted the pistol as the P80. An industrial manufacturer, relying on polymer molding and precise tooling rather than traditional handcrafted gunsmithing, had secured a permanent foothold in the military market. Gaston Glock approached firearm design through the lens of high-volume industrial manufacturing. The resulting architecture contains exactly 34 parts, a stark contrast to contemporary service pistols that often required over 50 separate components. Minimizing this count directly streamlined the factory floor. With fewer parts to fabricate, inspect, and fit, the company shrunk production times, minimized assembly errors, and lowered overall manufacturing tolerances. Using high-strength polymer for the frame served as a massive engineering pivot for volume production. Instead of spending hours milling heavy steel or aluminum frames on slow machining lines, the factory could produce a lightweight, durable frame in a rapid, high-pressure injection molding cycle. This process created a finished part requiring minimal post-mold machining, accelerating throughput. This industrial logic dictated the internal mechanics. The safe action system bypassed traditional manual safety levers, integrating three automatic passive safeties: a trigger safety, a firing pin safety, and a drop safety. This mechanical constraint removed complex external linkages, ensuring the pistol only fires with a deliberate trigger pull. In the factory, this simple layout allowed workers to assemble the firing mechanism with speed and absolute consistency. By prioritizing manufacturing simplicity during the design phase, the company created a platform tailored for rapid, massive-scale production without compromising structural integrity. Raw steel blocks arrive at the factory gates, where technicians subject each batch to chemical analysis and structural testing before a single machine spins up. This initial inspection establishes the foundation for every slide and barrel, weeding out any steel with microscopic flaws. Industrial saws slice the validated steel bar stock into working blanks. High-precision CNC milling centers take over, carving and shaping the raw metal into the recognizable blocky slide profiles of the handgun. Computer-controlled cutters slice through the steel, machining the internal slide rails, the striker channel, and the extractor port with absolute repeatability. Alongside slide fabrication, a separate precision line handles barrel production. Solid steel rods are drilled through, creating a smooth inner bore. The decisive transformation occurs at the cold hammer forging station. Here, a heavy pneumatic forging machine beats the steel barrel blank against a precision ground mandrel at room temperature under immense force. This intense compression stamps the polygonal rifling and the chamber directly into the steel while hardening the metal. By forging the barrels cold, the factory forces the steel's crystalline grain structure to align, improving tensile strength and wear resistance. This strict in-house control over the metal line ensures that the pistol's most highly stressed components achieve absolute dependability long before they ever reach the assembly floor. High-strength polymer granules arrive at the factory as the second major material stream, destined for the high-pressure injection molding line. Inside these dedicated bays, massive automated molding presses melt the synthetic resins and inject them into precision steel molds under immense pressure. A single injection cycle takes approximately 30 seconds, yielding a structurally complete frame with minimal post-mold work. The engineering focus here is strict tooling discipline. These industrial molds run continuously, engineered to maintain tolerances across 500,000 to 1 million cycles before rebuilding. Repeatability makes high-volume production of the lightweight platform viable. As the polymer cools and releases from the mold, the handgun's visible shape and design identity take form, ready to meet the steel components on the line. Before meeting on the assembly floor, the machined steel slides and forged barrels enter the finishing chambers. The factory applies advanced chemical and vapor deposition surface treatments, creating an ultra-hard, corrosion-resistant barrier designed to survive extreme operational environments. This step is about engineering durability rather than aesthetics. Immediately after finishing, these distinct component streams converge on the automated assembly line. High-speed robotic cells take over, fitting internal components, trigger bars, and spring assemblies with mechanical repeatability. This automation drives down dimensional variation, maintaining the rapid tempo of the factory floor. However, human operators remain integrated at key stations where tactile judgment is irreplaceable, manually testing the slide frame lockup and confirming the tension of the passive safety mechanisms. In this synchronized layout, 34 individual components unite into a single, integrated platform. With every slide to frame fit, the separate outputs of steel and polymer transform, and a completed handgun emerges on the line. The automated line ends here where human inspectors take direct control of the completed weapon. These specialists manually cycle the slide, checking the metal to polymer tolerances, and validating the 3 passive safety mechanisms by hand. From the inspection bench, each pistol enters the heavily fortified test range. Here, technicians subject every unit to a mandatory high-pressure proof fire sequence that complies with strict CIP and SAAMI standards. Workers chamber an overpressure cartridge designed to generate 73,000 pounds per square inch of force, 125% of normal service pressure. This single-shot test puts maximum stress on the cold hammer-forged barrel and machine slide. After surviving the blast, the pistol must cycle standard ammunition flawlessly to confirm the trigger pull and ejection timing are perfect. Once the weapon passes, the inspector stamps the official proof mark directly onto the steel of the barrel. The spent casing is sealed inside a yellow envelope displaying the test fire date, a physical record linked to the digital history of the build. Every certified pistol now carries a distinct digital fingerprint. The laser-engraved serial number on the slide, barrel, and frame links the handgun directly to its complete production history in the factory database. This system logs every manufacturing variable, from the raw steel batch used during CNC machining to the exact temperature of the polymer frame molding cycle. Quality control managers execute the final release filter, validating these digital records before authorizing shipment. Approved handguns move to the packaging line, where workers secure each unit in a high-impact case with its official test fire casing, manual, and security lock. Scanning the outer barcode registers the firearm in the global distribution database. From this secure hub, logistics coordinators arrange outbound transport, aligning shipments with strict international export licenses to supply global markets, maintaining absolute repeatability from raw steel to finished weapon. Today, this relentless automation defines modern manufacturing. Glock didn't just build a handgun, they engineered a flawless system of absolute repeatability that keeps shaping global industry. In a world of complex tech, simplicity remains the ultimate precision. What factory process impressed you most? Let us know in the comments.